So I'm a Google developer expert, and I do a lot of community activities. You can see me doing a lot of conferences if you follow my Twitter account. This year I also did this Master of Ceremonies gig for a conference in Switzerland, which was pretty fun. You can follow some of the topics that I cover in conferences I previously covered in blog posts. So usually I have more information in these articles that you can follow. So for example, this is covering GraphQL, which is cool. And I also cover it using React and Angular. Yesterday I was doing a React talk, but actually I'm mostly an Angular guy, so it's a little bit strange. I'm an international speaker, as you can see. I'm originally from Spain, although I've been living in London for the last 10 years. So I'm pretty much a Londoner now. These are some of the conferences I've been. So you can see there's a lot of Angular stuff going on, but mostly I'm happy to do, for example, Java conferences or maybe Google ones. There's also even an Android conference. So for the people that is a little bit scared to look into other stacks, this is really good. When you go to a conference, which is JavaScript conference, is good. But if you can go to some strange other technology just to see what's going on, it's really interesting. I'm also an Angular trainer, and maybe you can recognize some people in the picture. So this guy is Tomozo, and he's not one of the attendees. He was not an attendee. But I asked him, can you help me with this workshop? And he was all day on Twitter, which was not that helpful. But he's really a nice guy. In London, I run two communities. And one of them is Angular Zone, which you can follow, even from here. We run the meetups and we record the meetups so you can see what we are doing. We are also doing some interviews online, so maybe there's some topic that we do online that you can also follow. Mostly I've been covering GraphQL, and this is a community I just created a few months ago, and you can see that it's much more popular than my Angular Zone original meetup, which is a little bit sad, because I'm mainly an Angular guy, and then because I moved into GraphQL, the main technology used there is React, so now I'm also coding some React, which is fine. I mean, if you are good or you are proficient with Angular, it won't take you long to learn React. And this is the time to show some of my projects that I did this year. So this is Angular Cruise, and it was just happened in the end of May. And this is a conference, the first Angular conference that happens during a cruise. And it's a week, and the cruise departs from Miami and goes around the Bahamas. Maybe you are at the wrong conference. And these are some pictures. You can see me here as one of the co-organizers, also having fun. And the main attraction is not only the conference, which is an Angular conference, also supported by ngConf, but it's also the cruise. So you get to go to different islands and enjoy the cruise. There are also some workshops, and mainly you spend a lot of time in this like huge boat, which has everything like cinema, theater, swimming pools. This is not a party boat, but yeah, there's parties as well. So that's NG Cruise. Probably we're going to run the second edition next year. So just watch this. I also ran a bootcamp not long ago, and this is a very fun bootcamp. It's Angular in flip-flops, and I guess that you could also run it here in Odessa because you have the beach as well. So that could be an idea you can use. And this is a week bootcamp, and the interesting bit is that you have 3 days of training and then 2 days of working in teams. So you can also use all the knowledge that you have learned. And there's also some pictures. This is just a few months ago. I'm really stressed working on my bootcamp. You can see a few of the stuff. Oh, there's also these nice activities. You can also do surfing, because this is in Canary Islands. So there's also classes for to do surfing. And yeah, it's also time to have fun. I mean, always use a banana when you are programming. It opens, it unlocks, you know, some unexpected inspiration, creativity. Okay, so let's jump into the topic. This is more or less an overview of the architecture for testing. And we can see these two different aspects. One of them is the unit test, and the other one is the end-to-end test. How many of you are familiar with this stack? Okay, everyone. That's probably because Angular CLI. And we get this basically as a standard setup for Angular CLI projects, which is pretty cool. On the unit test side, we have these technologies here, and mainly there's the test runner. And now we have a few options. Maybe you haven't tried those, but if you're using Mocha or Chai, now Angular is also able to run this, which is not a common scenario because mainly Angular started with Jasmine, and it's just recently that you can use this tool. So this will give you a few libraries, so you can run your unit tests and expectations. And I'm going to cover that in a little bit more detail. On the end-to-end test, we have a slightly different stack. We have Selenium with Protractor, and these are using, under the lines, we're using WebDriver.js, and then also Selenium, which will be the tool automating the tests. Running these two different stacks, we have Karma, which will handle the different browsers and also give us information on the results of the test. So this is more or less the overall picture. As an overview of the different approach that you use when you are doing the tests is first you need to ask what you want to achieve with the test. So if you want to know if a certain method is working, you will use unit test. And this is more or less like a process that you would go through when you design your tests. The next question that you may have is this feature working? And then it depends what product are you building. You will differentiate these different features that you are worried about. And then for this, you usually use end-to-end tests. And these tests have different qualities, and we are going to cover this a little bit later in more detail. But usually this is what you can achieve with these different tests. If you have a meeting with a customer, you usually will be looking into end-to-end tests. You will never be talking about unit tests. So this is also part of another phase in the development process. There's also a final test, which is more or less like, is this product working? We are going to do a big release, and we want to make sure that it's working. Anyone knows what's going to be the answer then? Yes. Any other options? No? What's that?
Full test.
Full test. Integration test. No. It's called acceptance test. So you sit with the client, and then you just make sure that the client is happy what is being developed. So that's more or less the whole picture. So usually people concentrate on the unit test, which is just one step. And as you go into the release, you will have to go through these different steps of testing. Today we are going to cover the first two. I'm not going to cover anything on acceptance test, but just to make this whole overview. For Angular, we are really lucky because we don't have to build all of this stack that I presented at the beginning. If we are using Angular CLI will do this setup for us. So that's going to help us to get the project up and running, and also be able to use all of these unit tests and end-to-end tests. When we're using the Angular CLI, there are a few field name conventions that we can use. And obviously we have this component name convention. For the test, for this application component, we are going to see this extension, which is the spec. And this is also what we use in Jasmine. Spec is actually the test. Then for end-to-end test, we have a different extension, and this is going to cover the whole application. So this is slightly different. If you remember when we were introducing the end-to-end test, this is to cover a whole feature. So it's not that much focus, but it's a little bit more general. Then if we want to run this test for our application, we just run these commands. And the test commands is for the unit test, and the end-to-end is for the end-to-end test. So it's pretty easy to remember. You can also use some tools online, and this is the tool used by the Angular documentation. It's called Planka, and you can also run this test there. You cannot automate the browser, so you cannot run end-to-end tests, but for unit tests you can practice and play around. At the end of the session, I'm going to share one Planka that you have, I think, 32 different tests that you can follow. So while covering testing, there's these two concepts. And sometimes it's not clear what we mean with each of those. Who would like to give a try to what's the difference between mocks and stubs? Okay, maybe we have, if you can pass the microphone. Oh, you can pass that one.
Stubs doesn't have any functionality. It's just some empty action.
Okay.
And the mock has expectations before active phase.
Okay, that's pretty much it. So let's cover these two with a little bit more detail, but you were right on the spot. So I like to use this when choosing the right tool for the job. Sometimes you choose the wrong tool and you just get into trouble. So let's see exactly what it means. So mocks are usually being used in tests when you want to replace a complex object. And we don't want to use the original one because that's going to cost a lot of resources. So probably if you have been doing some automation, which I did some time ago with Excel, you don't want the Excel instance running in the background because that will be quite expensive. And you want to run your test still, but without using the real object. So what you will do is create this mock that will replace the Excel instance, but will be much less expensive on memory and resources. In Angular, we have some mocks already created for the Angular team, or by the Angular team, so you don't have to worry and create these objects from scratch. So we have this mock backend that will replace the HTTP module. Then we also have this mock event emitter. Sometimes we want to communicate or trigger some events to the parent component, and we are going to use these events emitters. So you can use this mock just to replace that. And then for the router, we also have this mock location strategy. So when you are developing these different tests, if you need to use these objects, you don't have to create these mocks from scratch. You can just use this from the core. For stubs, it's a slightly different use case. So as you were saying, these are actions, and what you want to do is you want to force a certain path for that action. So it's usually a method call, and you just want to, imagine you want to force not the happy path, but the error. what you will do is cherry pick that method and force the method to give an error back. So you're kind of changing the behavior of the method, the original method, just to get error handling covered. And this will be used in different tests. So maybe one test you want to use the happy path, for another test you want to test that it fails. And that all the infrastructure around the failure, it's covered. So this is how you would use the stubs. So as I was explaining, you want to change the original behavior and just push it in a certain way. So that's when you will use stubs. So these are quite different approaches. So we have covered mocks and stubs, and these are used in different scenarios. So let's cover Jasmine. I guess you are all Jasmine ninjas, so I'm going to cover this a little bit briefly. But it's a good base to start with testing. So this is, if you remember on the stack, this is the test runner. And this is where our test will run. And we have different helpers that will help us to run our test and check our expectations. The main concepts in Jasmine, they are based on this hierarchy. So we'll start from the suite, and then introduce our test. So this is kind of a wrapper. We can organize our tests by using these suites. Then within this suite we will define what is called specs, and this is actually what people use as tests. So the test will be contained in these specs functions, and the syntax is basically a description and then a function that will run when we run this test. While specifying these expectations, and they follow this syntax, so basically when we are doing designing our specs, we will check some expectations on what we want to achieve for that component or function. And these are the main ones. So I want to look into these two especially because they can be confused. And the syntax, as you can read, it reads like I expect X to be, and then the value that I expect from that. It can be a call, it can be a value, and this is exactly what we will achieve with these calls. And you can see that the expectations is using this expect, and then following there's a current function which is the matcher. For these two, 2v and 2 equal, anybody wants to give it a try of what's the difference between these two? I know it's Sunday, it's a little bit, I'm asking too much maybe, but it's quite practical session, so. No?
Anyone?
Okay, there's a brave.
Expect to be used by reference, and to equal is for objects type by value.
Okay, well, it's a first try. I mean, it's not exactly that. Anyone else?
Once more. So to be is referring to the class of the object, and to equal is actually an equality check. So you can say to be a function, for example, or to be a certain object type. Then to equal is the entity check.
Okay. It's almost there, but there's still a few things missing. So the main difference between these two is 2v is the triple equal, is the reference check. And to equal is the deep equal. So when we use complex objects, it's going to look recursively, it's going to look into all the properties and check that all of them are the same. So basically the first one is really cheap and the second one is really expensive. depending on what object you are checking. So just be aware of these two differences. One of the main worries when you are building your test is that they are fast, because probably you are going to run these tests a lot. Maybe you use continuous integration and you want to make these tests really lightweight. So to be triple equals really fast is only the reference check. 2 equal is the deep equal, so it's going to run. I mean, you could implement it yourself, but better use this one when you want to check the inner objects that they are also the same. Okay, so let's see a basic test. So we have this calculator, and we only have the add function, which is using the EMAScript6 arrow functions. And we just have these two arguments, and then we just return the sum of these two. Imagine we want to test this calculator. And I go ahead and use this Jasmine, describe and it. So one of the features of Jasmine is that we can read, it's easy to read, and also for people that are not developers, they can follow, they can read this test. So this, when it's run, it will read like the calculator should add two numbers. So it's really easy to follow. What I'm doing in this test is checking that when I run this calculator at 1 plus 1, I will get the value 2. How many people think that this add calculator is done? We are done with the test. No, not even far. This is one thing with test. Test is a little bit of an art. I mean, some people use TDD, which will start from this test, and then the implementation will follow this test. So the expectations will drive development. Some other people will add the test later, and then there's so many ways it can go wrong. You can add some expectations, like this one, and it's just not enough. There's also some other things that different developers see the expectations in different ways. So for example, another developer would say, okay, what happens if it's not a 1 for the argument? I want to check more values. Maybe I want to check negative values. Maybe I want to check the extremes. I mean, if we're using integers, maybe I want to try what happens when I use the maximum integer or the minimum integer. Or what happens if I use a string? Is my calculator going to work? It's going to behave in the way that I want? This is something that it's different. So some people may say, okay, if I use this add with strings, it should not work. Some other people can say, oh, if the actual string is a number, then use that number in the string to do the calculation. I mean, it may change. So going back to the definition, this is like why testing is a little bit of an art. And it's not clear when you are finished. Because we could spend the whole morning adding more expectations, and it will be useful and valuable. Usually, you need to stop adding expectations when these expectations are not followed by code. If there is no extra code to be added or extra functionality, that expectation is useless. Because if there is no code supporting the expectation, it just haven't add any value. Okay. So in Jasmine we have different phases. We have this, what is called the setup and also the tear down. And this is the two phases that happen before and after each spec. So we have these hooks that we can use. Before all will happen once. Then before each will happen many times before each expectation. After each we'll do the same, but after. And then we have also this hook which we can use at the end of all of the tests, and happens only once. Some useful techniques that I learned from my testing sessions. So one thing that you can use, and it's quite useful, is nesting the suits and using the scope. Obviously, you don't want to play too much with that if you create some, global scope. But if you want to automate, for example, the unit tests going from a range, that could be very helpful. There's some utility APIs that we can use, and this will help us to run our tests and also leave some messages for other developers. So for example, fail message will just trigger an exception and pass this message to the final test report. Also, imagine if you are testing, if you're running some tests and you cannot fix the issue, maybe you want to leave a message for the next developer, or you want to leave a message so when you are doing the next meeting, the next stand-up meeting, there's a message explaining why that unit test didn't pass. So you can use this pending, and it will just disable the unit test, but it will just leave it reported. So these are all useful methods. You can also play with this tool, and these are quite useful as well. So imagine you have a huge, massive test, maybe 200 unit tests, and there is one that is just making fail the whole thing. And you just know what to do to fix it, but you don't have enough time right now. So what you can do is just disable it. You use this X, and it will just disable the test, but still run the other ones. The opposite, you can use it both for the suite and the spec. The other one that is quite useful is when you only want to focus in one test. So imagine I have 200 tests, but now I only want to debug one. I don't want to run the other 199 tests every time that I do a debug cycle. So let me just show you so you can get the feeling. So this is the article when I cover all these testing scenarios. And this is the actual planker. So this is a big, as you can see when it runs, this is like a big unit test to run online. This is like 26 different cases. So let's take one of these. And I'm going to just take one just to show you how it works. So I'm going to pick the event emitter test, and I'm going to change it and use the focus. So now you can see that I just run 6 instead of the 26. I just run 6, and then I can do the same. So if I take one aspect and I want to focus in just maybe in this tool, now you will see that from all the tests, I just focus on that suit and also in these just 2 tests. So I can use my time much better. Okay. So these are a few techniques that you can use. There's also a nice feature from Jasmine which is called spies, and this will help us in some of the tests. And we just cover the steps, and for Jasmine spies, this is what is called a test double. So it will seem like we're using the original method, but we can change the behavior, more or less like to implement a step. The functions the features that we get is that we can record the calls that we did using a spy. We can also record the arguments that were used, and we can also affect the return values. And in some cases, this will be really helpful. So let's cover this pretty quickly. So if we want to track the calls, what we will do is we have the original calculator method. And in this test, I'm actually using the test to test a spy. So this is a test for the spy, and I'm doing these should track calls, but not call through. So it will record the calls that I do using the spy, but it will not call the original method. The way we create the spy on the add method is passing the original object and telling which method I want to create the spy on. So this will create the spy. The spy is going to replace the original method, so the spy is living in this calculator.add. So this is not now the original method, but it's the new one, which is the spy. The moment I call the calculation add method, now I'm using the spy. I just replace it when I did this call. So when I do these expectations, when I run these expectations, now I have access to these methods. And they live in this reference. So this is the prototype. So I can access the prototype and I can check how many times it has been called. And I can check that value. I can also check the times. So this will tell me if it's been called or not. This will tell me how times it was called, and this will tell me which using which arguments. So I get some nice features from this. The only thing that it's a little bit strange is that if I actually check the result, it's not going to be 2. So I run the add method with 1 and 1. I was expecting to get a 2, but I get an undefined because it's not the actual original method, but it's the spy. And the spy blocks the calls. So it doesn't call the original method. And this is more the idea of a stub. So we want to change the behavior and then decide what is going to happen. If we want to change that behavior, which is the default, we can use this option which is called end call through. And this is more or less like the setup for the spy. If we create the spy and use this setting, what will happen is that we will get the result. So we will get the same features, but now we will get the result. It will go through, make the call, and get the result back. If you want to get the spy to the default behavior, you can use this and stop. At this moment, it will behave back to the original behavior, which is like stop the call to being made. So that will be undefined instead of 2. Okay. Obviously, you can, because we have the spy and we have full control, we can also decide what will be the result. And this is an example of setting a return value. So instead of getting the 2, now I can say, okay, instead of giving me a 2, just give me 42. And that's now the behavior because it's the spy instead of the original. It's a little bit evil, but the thing is, because we don't want to call the original method, which maybe is expensive, we just want to make sure that the calls are working as expected. So it makes sense to use these spies. We can also pass, instead of one value, we can also say, okay, the first time that you call this method, you get this value. The second time, you get this other value. And you can use this syntax to do that. And as you can see, if I run this, I will just get the values that I set for the spies. These are all tests. If you run these tests that are on the planker, you will see that these tests are passing. So we can also use tests to check the behavior of spies. And sometimes it's also nice to show features to use a test because it makes it really clear. Another scenario is we want to check how the error handling is working. So in this case, what we can use is like, okay, if you call this method, just throw an exception. I don't care what happens because it's a spy, I'm just replacing the behavior. So basically I'm implementing a stub. And I can decide, I'm just using a string, but you can use a new error instance, and it will do what you I mean, you can then test the error handling. One thing to take into account when testing error handling is because the test, because of how exceptions work in JavaScript, if you don't create closure, like I did here with this anonymous function, the exception will just break the test and just leave without giving you the value back. So this is something that you may be a little bit shocked. You want to test an error scenario, and then your test just breaks and gives you no expected results. You just need to wrap the call in this anonymous function or just a regular function, and then it will work. So there are different ways to create these spies, and we just saw using the original object and then telling what method we want to use. There's also this other way. So instead of using a calculator object, I can just say, I want just to create the add method without any object around it. And then we can use this to callbacks. So when I don't have an object, I just have a function. This will be the option. So now I can call the function, which is created by the spy, and I can do the checks that I was showing before. But this is a good example for a callback, because then I can pass this into a set timeout, and because we don't need the surrounding object, that will be a good use of a spy. So then what I can do is, after 100 milliseconds, check this to have been called, just to check that the call was made and the callback was successful. So these are a little bit more complex scenarios. Sometimes you have a complex object and not only one method is on that API for that object. So we can also use an array and create a batch of methods. So that will also work. And then we can also use all the previous features that we saw from spies. So now we are not using the original object and original methods, but we are just creating both. We are creating so it's the spy creating this for us. And then we can use it as we did before. Okay, baby steps. So now we know a little bit about Jasmine. It's good time to move into Angular. And let me just check. Oh, not good. Okay. We have two different sections. We have end-to-end after this, and then just the wrap-up. So maybe I'll try to cover Angular testing in the next 5 minutes. Yeah, because I mean and then you can maybe see end-to-end testing later. So for the testing APIs, we have few of them, and these are covering different scenarios. So the inject is the dependency injection that we use in the constructor of components. That will do the same for our test. And the test bed is exactly replacing ng module. So whatever you know about injecting dependencies in a constructor or implementing ng modules, in tests, you can use that experience to use inject and test bed. When you are dealing with a synchronous test, you can use async, and that will bring a zone. If you are not familiar with zones re-implement the asynchronous code, the synchronous APIs from the browser, and call the change detection on the Angular environment. So when we have integration with third-party libraries, we don't need to worry of triggering this change detection on our own. It will be zones taking care of that. The other way we can use test asynchronous behavior is using the fake async and tick. And this is when you want to batch. Imagine you have a complex object and you want to change different properties. You don't want to trigger change detection for each change. So you want to do all of these changes in batch. You will use then fake async, and this queues all of the synchronous processing in a queue in memory. And then when you want to trigger all of the changes at once, you can call tick to do that. Okay, the setup, not too much interesting. This is also why I call testing recipes, because you shouldn't be memorizing this, but have this as a resource. So you can check this later. For testing a service, we have a simple service with some information coming from this get method. And the way we set up the test, now because we are in Angular, we need to use this test bed. And that will be the ng module equivalent. So I just need to take the service into my test, and then I can check. I can use dependency injection to create the instance and pass it into this argument, and then I can just do the expectations as normal. If we do a little refactoring with the inject, what we can do is use the scope of the suite, and just get the instance. So that setup is exactly the same. So this is the ng module for the test, and I'm just taking the provider that I need. And when I want to get the instance for that service, I do it once, and if I have 20 specs, I don't need to call the inject for each of them. Before, we were using this as an argument. So I can remove this inject, put it on a before each. It's a small refactor that will make your test a little bit nicer. So we have moved the inject to this before each. And then we can do the test, and it looks much nicer. For asynchronous testing, yeah, that's more or less the feeling. Usually what you get when you are dealing with asynchronous code is you get a timeout. The moment you get a timeout in Angular is the moment when you need to look into this. But that's the feeling, yeah. Asynchronous APIs, so we have these ones. And don't forget you also have this Jasmine done, which handles asynchronous tests. I wouldn't recommend it because it won't catch all of the different scenarios. For example, if you're using observables and ArcJS, Jasmine is not aware of this. So the best bet is to use async, because that has all of the bindings that are necessary. And yeah, this one is for batch asynchronous code. So let's see a simple HTTP service. Nothing special, we just have a HTTP GET call with some access to a file, because it's simpler than a backend. You have this recipe, which looks quite complex. It's probably going to change in the future. This little code here is to make sure that we get a new instance before each spec. You may see different versions of this recipe, but this version is a little bit more strong, because it creates a new instance of a HTTP service before each spec. We use the same refactor. In this case, we get two different instances, the mock backend and the service. And this code, it looks a little bit more funny, because we need to provide the response. So the code looks a little bit cumbersome, because we have these observables. So we need to subscribe and use that connection to create the response. But once we have the response, every time that we call the service, and also because HTTP calls are now returning an observable by default, we also need to subscribe and do the expectations within that subscribe callback. It's a lot of code, but you can come back later. This also is important. When we have a component, we also have to deal with change detection and also the rendering of the template. The first test that I showed, it was just a service, which is just an object in memory and has no change detection whatsoever. So let's just look at this pretty quick. So this is a very simple component with just a hello and some binding that we can use as this. So I can pass some name, and I will get hello using that name. For this we need something new that is called a fixture, and the setup looks exactly the same, so we just use the ng module declaration. Now we are using a component, so we use a declaration, and to create that component what we need to use is this fixture that will handle the change detection and the rendering of the template. So in order to do that, we use this testbed create component, and that will give us back this fixture. The fixture has few properties that we can use. One of them, it will give us access to the actual component. So this is the instance of the component. If it has different public properties, we can access and it will behave like the original object. The next one is the native element. So when this component is rendered, it will give us access to the final object. So in this case, the final object will be this greeter element. So that will be the native element. And then we have also access, so that's also the original DOM element API. So this is the DOM API from the browser. And the final one, which is the debug element, it gives us access to the Angular object. So if we are dealing with directives, or we are dealing with any of the other components, part of Angular, we need to use this one, this API. And we will see an example in the next slide. If we are using these external HTML files, it's a little bit more complex code, because we have to compile these external files, and that will be asynchronous now. But usually, if you are using Angular CLI, the actual templates are being compiled and inline, so this is not that common anymore. When we implement a test with a component, it will look more or less like this. So we will use this async just to cover any asynchronous code, and we will have to run the detect changes. And this is, imagine you want to change that name property, just to change the hello and the name of the attribute that we passed. We don't want this to trigger change detection automatically, so we need to use these detect changes, and that will trigger the change detection and re-render the template. What we need to do then is use this when stable, which will trigger when the rendering is done. And this is because we can have some child components, and this can take a little bit, so it won't be synchronous. Then we can use these different APIs. So here I'm using a native, the DOM native APIs, and you probably are familiar with those. But then you also have access to the Angular ones, which look very much the same, but also give us some other nice features. From the Angular APIs, you need to access the inner text, and through this native element, which is a little bit more code. Okay, just one more case. So for fake async, we just use fake async instead of async. And in this case, we are patching the changes. So even if I run some asynchronous code, it won't execute. It will wait until I call tick. So it will just make this code a little bit nicer. We don't have this when it's stable that was in the async version. And then we can use exactly the same code. So when we're using fake async, our test will look a little bit nicer, a little bit flat. If you see, the code here was inside this promise. Okay. Only one more case is called shallow testing. For shallow testing, it's when we have a very complex template and some of the components we don't want to test. Imagine you have an e-commerce site and you just want to test the top navigation component. What you will do is use this no error schema and just import the component that you want to test. It can be one of the least details component that it's somewhere in the main template. And this will allow you to run the test and not throw any errors because the other elements are not defined. Okay, so very good. We don't have time for end-to-end testing. Let's just move. Okay. So you want more? I have more for you. You have this planker that you can use. It's covering all of these topics, also the spies. And you can check a more verbose explanation of these scenarios in this blog post. And that's all.